I wanted to give you a few more examples of extraneous problems and their solutions. So I've got 3 problems on this page. If you want to take a second, here are the 3. So if you need to pause and write them down, if you want to try them on your own, do so now. But I'm going to go ahead and start working on them. So starting off with problem number 2, because we did one as our intro in class today. I'm going to rewrite this as x plus 5, and then separate into the positive and the negative version. So negative 3x plus 7. When you change the sign, you have to remember to change every single sign in there. So for me, that means I've got the positive on the left. So right here, 3x minus 7, no change, versus the negative on the right, where everything changed sign. When we say negative, what we're really doing is multiplying that whole batch by a -1. So let's go ahead and work these out. We have to do both of them, and then we have to check our answer. So I'm going to subtract x. I get 5 equals 2x minus 7. I'll add 7, and I get 12 equals 2x. I divide 2, and I get that x equals 6. So there's one answer. Over here on the right, same process, subtract the x. I get 5 equals -4x plus 7. Subtract the 7. I get -2 equals -4x. Divide the -4, and I get 1/2 equals x. Now, here's the extra part of these problems. You have to go back and plug in your answers to make sure that they work. Again, I like to pick either the smaller or the negative answer. So in this case, I'm going to go ahead and test x equals 1/2 first. So if I test x equals 1/2, when I plug it in, and I'll use purple. When I plug it into this whole original piece, I'm going to have to write out 1/2 plus 5 equals 3 times 1/2 minus 7. Now, here's the beauty of these problems. Your absolute value on the left, 1/2 plus 5, will always come out to be positive because it's inside absolute value. So I'm just going to leave that be and say I know it's going to be positive. Over here on the right, I'm looking at 3/2 minus 7. Remember, that's 3/1. So when you multiply your fractions, do top times top, bottom times bottom. And I need to create a common denominator. So 3/2 minus that 7 is going to become 14/2. If it needs a denominator, multiply it by what it needs. So there we go. And this is going to get me -11/2. Well, that completely conflicts with our evaluation of the left-hand side. The left-hand side has to be positive, but we're getting a negative on the right. That means x equals 1/2 is what's called an extraneous solution and is not an acceptable answer. Now, we can go through this exact same process with x equals 6. And as a matter of fact, I'll try to squish it in. Ooh, that's going to be tight. Let's see if I can make it fit. We're going to have 6 plus 5 equals 3 times 6 minus 7. Again, taking this answer, x equals 6, and plugging it back into the original to make sure that it works. So I've got absolute value of 11 equals 18 minus 7. Well, absolute value of 11 is 11. 18 minus 7 is 11. Sure enough, this solution is good. So even though you do come up with 2 answers for x, one of those is not an answer. One of those is extraneous. So I'm going to move through problems 3 and 4 a little bit faster and narrate a little bit less. I'm going to do this really quick. If you need to pause it and check your work against number 2, this is your chance to pause it and check your work. And I'm going back to number 3. So looking at number 3, again, I'm going to say, okay, the absolute value, 2t minus 3, is going to stay the same. 2t minus 3, 2t minus 3. But one side is going to be positive, so one side is going to stay the same, 3t minus 2, and the other side is going to become negative, so everything changes the sign, negative 3t plus 2. So from here, let's go ahead and solve for t. The process will be the same for either side. You can change it if you want to, but you don't have to. I'm going to change this color so that you know it's the negative 1. All right, so right here, I'm going to go ahead and subtract 2t. Get negative 3 equals t minus 2. I'm going to add my 2. And I get negative 1 equals t. Going to repeat the process over here. And you know what, actually, I'm going to do something a little bit different. So I can go through the exact same steps, or I can change it to better suit this specific problem. So I'm going to instead add 3t and then add 3. Now, you don't have to do this. I'm just trying to demonstrate that there are multiple ways to solve these problems, and this is an alternate way. 5t equals 5, divide the 5, and I get that t equals 1. So I'm going to scroll down and make that show up down here. What we have to do now is take that t equals negative 1 and t equals positive 1 and test them. So we're going to plug it into the original equation that we start with. So we are going to say absolute value, that's a giant absolute value marker, 2 times negative 1 minus 3 equals 3 times negative 1 minus 2. Okay, so we take it and we put it back into the original. Same thing right here. Absolute value. 2 times positive 1 minus 3 is equal to 3 times positive 1 minus 2. Always putting it back into the original. So if we start off with the negative 1, I'm going to look at this and right away say we're going to have some issue here. Remember, this side, always positive. This side, I'm looking at negative 3 minus 2. That's a negative 5. That means that's not a solution because your left-hand side is positive. And what you end up with is you're told at the end that you're getting, let's see, 2 times negative 1 minus 3. So you're getting 5 equals negative 5. That is a false statement. Therefore, that t equals negative 1 is not an answer. Over here, we get, right here, we're looking at 2 minus 3. So absolute value of negative 1, which is positive 1, equals 3 minus 2, which is 1. So there's our one and only solution, t equals positive 1. Final problem, and then we're done with this video. When we look at this problem here, we've got a little extra work to do. So we still have to isolate the absolute value, which means that we still have to first add the 3. So 2 absolute value, z plus 1 equals z plus 1. And we still have to divide the 2. So you still need to correctly isolate the absolute value. You can't do positive and negative until the absolute value is by itself. So absolute value of z plus 1 is now by itself, and it's equal to z over 2 plus 1/2, which means that we can now split it into z plus 1 equals z over 2 plus 1/2, and z plus 1 equals z over 2, sorry, negative z over 2 minus 1/2. Remember, positive side, negative side. Solve for both z's. Now I'm going to cheat a little bit. I'm going to do this. I'm going to take all this off this page and get myself a nice, clean, fresh page so that I can work on the lines. All right, so all that I did was I saved myself a little bit of headache by giving the lines back on the screen. And we're gonna solve for z. So starting off with the positive blue side, I'm gonna do this. I'm gonna make everything, I'm gonna get rid of the denominators. So the way that I'm gonna get rid of the denominators, I'm going to multiply the entire thing by 2. I put parentheses up because I'm going to have to distribute that 2, and that's going to turn into 2z plus 2 equals z plus 1. That's just a little trick there. If you want to get rid of your denominators, multiply them away completely. You do need to do it correctly. You need to multiply to an entire side, which does mean distribution. All right, so solving for z, subtract the z. I get 1z, I'm not even gonna write 1, I get z, then I'm gonna subtract the 2, z equals negative 1. Over here, I'm gonna perform the exact same process, multiply away the denominator, 2z plus 2 equals negative z minus 1, and then add the z, I get 3z, subtract the 2, I get negative 3, then divide the 3 to tell me that z equals negative 1. So this is a very interesting problem here. Both our answers are negative 1. I really hope I did this problem correctly and I didn't make a mistake somewhere. Let's find out. The way that we find out is just by plugging in our answers. So we're going to go ahead and plug them in. Here's the catch. You do need to plug them into the original at the top. So that means that I have to take 2 absolute value, negative 1 plus 1 minus 3 equals negative 1 minus 2. I have to check and see that this does indeed work. So when I work this out, I get 2 absolute value 0 minus 3 equals negative 3. Well, absolute value 0 is 0. Anything, 0 units away from 0 is 0. 2 times 0 is 0. So negative 3 equals negative 3. So sure enough, those are both good solutions. And if you catch an error that I made, you let me know, but otherwise that's it for extraneous solutions.